On top of the I, there's actually one of those double dot notations. Anyone know what that's called? It's called an umlaut. That comes up in crosswords a lot if you do crosswords. U-M-A-L-T. Comes from German, and that makes the sinusoidal sound. So sinusoidal. Definition, what's a sinusoidal function? It's a repetitive oscillating graph. What does the word oscillating mean? Physics people have probably heard it before. What does it mean? Sorry? More specific? Anyone have a clue? Oscillate means to go back and forth. So you'll often hear people are oscillating on a decision. It means they're like, I don't know, I'm going back and forth, I don't know what to pick. In terms of a graph, it looks like this. Up, down, up, down, up, down. Where have we seen that before? Yeah, that's our sine graph. So many applications. Tomorrow, maybe the next day, we'll see how much we get through today. We're going to look at some of them. I can't even begin to explain. If you've done physics, you've seen this before for sure. Have you guys done harmonic motion already in physics? So when you take a spring, like a slinky, and you let it go, the motion it makes as it goes up and down, that's an oscillation. Whenever you're hearing something, so me talking right now, sound waves are oscillation because it's actually vibrating back and forth. Who are the guitar or string instrument players? Anyone play guitar or string instrument? When you pluck the string, it's actually vibrating back and forth at what makes a sound. This is all sinusoidal stuff. Tomorrow we're going to look at different other types of applications, but if you go basically into any kind of science, at some point you're going to hit a sinusoidal function because they come up all the time. Here's what a sinusoidal function looks like. We've seen this before. These are just sine or cos graphs. Tell me what you know about A. What's a number that's in front of a function outside of the brackets? Vertical, stretch, or compression. We talked a little bit on Friday in terms of a sinusoidal function. We call this the amplitude. And that's just the height of a max or the distance to a min. And B, in terms of transformations, is, and you have to remember there are imaginary brackets around here. We just get really lazy and don't draw them. Horizontal, stretch, or compression. And we talked on Friday. Anyone remember the word? Period. And if you're a physics person, frequency, which is the same as wavelength. Okay, that's the length of the graph, so one repetition of the graph. C in terms of transformations. Horizontal translation. Here's a new phrase for you. It's called the phase shift. And you can think of that like phases of the moon. And if you think in terms of the moon, every night it rises, then it falls, then it rises, then it falls, then it rises, then it falls. And does that go on forever? So if you look at any kind of sun movement or moon movement, that's all sinusoidal functions. And D in terms of transformations. Vertical translation. And in terms of sinusoidal functions, it's called the center line. So it's a line that runs halfway through the graph. So mathematically, we're not doing anything different. All we've done is just call them something different. So first thing we're going to do is just look at the equation, and we're going to identify what is the amplitude, what's the period, what's the phase shift, there should be a comma there, what's the center line, etc. Then we'll go backwards. I'll give you the period and the amplitude, and you're going to write the equation, and then we're going to actually do some graphing. So nothing different in terms of the math. We're just calling it something different. So for each of the trigonometric functions, sinusoidal, trigonometric, exact same thing, identify the amplitude, period, phase shift, and center line. So we call it the A, the P, the PS, and the CL. Hopefully those are obvious abbreviations. Amplitude, where do I find that in the equation? In the very front, so the amplitude is 3. What that tells me in terms of this sine wave, it's going to have a halfway mark because we know that it's repetitive or symmetric. It tells me the distance from the center line to a max or the center line to a min is 3 units. And it doesn't matter where I count it, it's always going to be 3 units. That's what the amplitude means, is the height of the graph. What affects the period or the frequency of a sinusoidal graph? So where in here? It's the horizontal stretch or compression. So we're looking at what's the number between sine and x. There's just one, so the period is always 2 pi divided by the b value. And I'm just going to box that in red. That's going to come up a lot. Where does the 2 pi come in? Because it's one revolution of the circle, which we know is 2 pi. So in this case, it's just 2 pi divided by 1, which we don't see. So for this one, it's just 2 pi. So that means we didn't horizontally compress or stretch this. It just is what it is. And what that means is, from the start of the graph, so 1 max, 1 min, to the end of the graph, so we call that one repetition of the graph or one cycle of the graph, that length is 2 pi. Phase shift is our horizontal translation. It's whatever number is in the brackets with the x. There isn't one, so this would be 0. And the center line is the vertical translation, so how far we've moved it up, in this case, would be 4. Letter B, amplitude's always the number in front. Ignore the negative. Don't look at the negative. The negative has nothing to do with it. Let's talk in terms of transformations. What is the negative? It's a vertical reflection. So show me your hand, thumb up. Show me thumb down. Did we change the width of our hand? Right, width didn't change. So that negative is not going to affect the amplitude. It's not stretching it at all. It's just the number that stretches. So amplitude in this case is 2. The other way you can think about it is amplitude is a distance. It's a height of the graph. Can a height be negative? No. So the negative is never going to come with amplitude. That's just a reflection. Period is 2 pi divided by whatever the b value is. B value is whatever is stuck between cos and x, or cos and theta, or sine and theta. So in this case, the b value is 1/2. And then we're just going to simplify that. How do we divide fractions? Flip the second one, so this would become 4 pi. And that just means we took the standard 2 pi and stretched it out, right, which is our 1/2. Phase shift is the horizontal translation, so anything that's in the brackets with the x that we're adding. Are we adding anything? No. And the center line is the vertical translation, so all the way at the end. Are we adding anything? No, 0. Try this one with a friend or by yourself if you're feeling antisocial.